Imagine you need to move a stone block weighing several tons. Doing it by hand is impossible, but people managed to do it thousands of years ago. For example, during the construction of the Egyptian pyramids. Massive stone blocks were moved and lifted using simple machines, including planes, pulleys, and most importantly, the lever. It was Archimedes who first formulated the principle behind all those devices. With the right mechanism, you can gain mechanical advantage. You apply a small force and get much larger output. But there is a catch. A lever gives you more force, but you pay for it for the distance or time. A pulley lets you redirect force. You pull down to lift something up. Add a movable pulley and you gain even more force, but you have to pull for a longer distance. An inclined plane makes lifting easier, but increases the path. So, you're not creating force out of nowhere, you're simply controlling it, and over time, humans took the next step. They stopped merely moving objects and started triggering processes. That's how the button was born. Press and something happens, release, and the system returns. At first, everything was very simple. Take a mechanical doorbell, for example. You press a button, a small cam pushes a hammer, the hammer strikes a bell, and the spring returns it to its original position. You control the system, but only at arm's length, and then a new question arises. Can you control something from a distance? In the 19th century, this became one of the key technological challenges. Against the background of light signals and smoke signals, the first electrical telegraphs began to appear. One early design created by Francis Ronalds looked quite unusual. Two identical dials were connected by a wire. Instead of numbers, they had letters and symbols. Clockwork mechanisms kept the dials rotating in sync. When the dial reached the desired letter, the signal was fixed and transmitted to the other end. So, let's try to send hijack. Sounds brilliant, but there was a problem. Let's try again, but this time rotation out of sync. If the mechanisms fell even slightly out of sync, the message turned into nonsense. Ronalds' telegraph never became widespread, but it proved something essential. Information could be transmitted over a distance. Other systems appeared as well. For example, Paul Schilling's telegraph used electrical magnetism and needle indicators, but it required several wires to operate. In some versions, up to 6 signal wires. Later designs used fewer wires, but they were still complex and inconvenient. And then came a real breakthrough. Samuel Morse proposed a radical simplification. Instead of complex mechanisms, just two signals, a short press and a long press. Only two states, and that was enough to encode any text. One button, one wire, and the message could travel thousands of kilometers. Let's send the same message in Morse code. For the first time in history, humans gained the ability to control information at a distance with a simple press. Further development of telegraphy led codes such as powdered code, where combinations of the signals were used. This made it possible to move from a single button to keyboards and significantly speed up text input. Keyboards became part of computers and eventually part of everyday interfaces. But the essence didn't change. Buttons became a universal way to control systems. Once, to move a stone block, a person needed their whole body. Today, a single finger is enough. But in a sense, nothing has changed. We still don't create force out of nowhere. We simply learn to controlling it more precisely and over greater distance. I created two simulation programs for this video, one for Ronalds Telegraph and one for Morse Telegraph. They are open source and you can download them using the link in the description. I hope you enjoyed the video. Let me know what you think in the comments. Thanks for watching and see you next time.